Today I will cover something is important, how to integration machine learning with seismic inversion. This software called Attribute Studio for Geomodeling. This is focused in attribute and machine learning. We can import data from here. It is easy, import wells, import fault, and so on. After import seismic data, 3D seismic data, we can find the window here like seismic, fault, and others. We can go to seismic, and now we can find our data here. So now it's good. We can also import horizon and others. We have many format to accept it from others. From Kingdom, the best format is OWX for wells. It is automatically export all data and imported all data, and such a very, very great option because it is exported formation top and logs and everything. It's good. Photon also is good. So you can, geographics also is good. Now, after imported data, I will start from well. So I will create well cross section like this. That means I will display well cross section. So it will be easy from here. I can click here and I will create the new well if I want. So now this is a technique. Also, we have option to test the data as I told you before. This is the Samanga Sea and this is Intramanga Blue. So this is the top of reservoir. As you can see, we have low gamma ray, we have low neutron, and we have high resistivity, very good. And we have water saturation calculated, and phi effective is also very good. And impedance is low, is accepted also. Mu also accepted. Lambda mu ratio is very low, is good. VP and VS is low. All the Bosa ratio is low. So all the parameter is very good and accepted for me. So now we can also mix with others data because this is very, very important. We can display some seismic attribute data. So this is a relative acoustic impedance. This is the sweetness here, and we have others. So let me to make it easy because I like to add some advantage to our presentation. Just a minute. Okay. Okay, I will, I don't know, suppose it is working, but it's not, it is like a pen, but it's okay, no problem, because I wanted to highlight something. By the way, we have something is very important here. The relation between data is reasonable and is good also, as you can see, zonation. And also I created fishes classification, as you can see. Usually we have averaging data. So this is, we suppose upscaling is different from norm because the depth and ranging is different slightly usually, but we need at least some features we have. To do that, we can make something else. We created a crossbot between VB and DBS and also created and impedance. So let me show you because this is maybe important to see this relationship a little bit different from others. And now we have created this relationship. Suppose it is working, but it will take some times. That means we created some BDF distribution. So BDF distribution, that means some point in this class, and when this class is isolated from other class, that means we have good isolation. Good isolation and good BDF. So not interference between clusters, as you can see here. So this is good option. So now we can create some polygon. It is easy to create this polygon from here, and we can display this polygon in the curve. In the log like this, so you can see now by clicking here. So if I click here, I can remove the polygon. So if I return again, I can return again and highlighting a polygon, as you can see. So this is the integration between the polygon, and this is interactively. We can edit the data directly and see the interactively of increasing or decreasing data automatically. So this is the key point of integration data and create the classification, something like this. So we can create many relationships if you want between others data we have. So this is the technique. Usually it takes sometimes like this. So we have other relationship here, and maybe we can have other relationship here, and see on which one is maybe reasonable for you. This is demo data, so also sometimes we have some problem with the software because this is new version under testing. So this is not normal version. They send me before the announce the new version, by the way. So let me to do that again. So after cross-plot data and create the logs, so now we need to create the first step for machine learning. It is called the strata slice. So the strata slice, I will give you show you some cube to see what is the meaning of strata slice. This is strata slice. So I created horizon and extract many sweetness or many attributes parallel to horizon as a volume. So now I can move this strata slide as you can see here. So to see the change, but this is different from time slice. Time slice is flat, but now I see the data parallel to feature as you can see here. So I can see data carefully in different levels as you can see here. So this is very good because we need to isolate it and discover some features like we have here. So now we can discover some feature and the edge of reservoir we have. After we can do that by horizon and picking horizon, or maybe we can import horizon. We have option for picking horizon, but it is not topic today. After we picking or import horizon, we can right click and create strata, build strata grid. That means we will build many horizon parallel to the interested horizon we have above and below. We can control the number and horizon, and we can create some interval if you want. So this is one of advantage. I like this option, by the way. After create a strata slide, so we can go to another thing. We can find data under interval. So interval here, we can find our data here. We have good option in this software, by the way. We can click in data automatically. He brings the data in project T. In other software, it will be difficult usually to search and find, but now we can just click here. He can put interactively the position of data here. So now this is a cube represents this data we have. So it will be good to display, and we can change other attributes. This relative acoustic impedance here. And this is instantaneous amplitude here. So this is very good to extract many attributes. To do that, we can just need to right click, and we have all options to extract, to calculate, to do anything, and created faces unsupervised technique here. So if you wanted to create unsupervised, we just click here, and then we can choose data we want here, something like this. And we can choose deep learning option and click OK. Now we create unsupervised, but we need to determine the classes we have. By the way, I created some classification. I can show you some cluster unsupervised technique to show you. By the way, maybe this is, I don't know. Yes, this is some of the technique classification, and this is also some of classification. This is also some classification others. So I created many classification and tested many times until I get maybe one of the best classification by many method is Bayesian. One of the technique to combine between logs and also seismic. In this technique, we can isolate it feature by integrated log, VB and VS of log with crossplot and integrated the predicted data. So Bayesian, one of the technique of physical, because it's combine both two. Also, if you think this is good, I created other one is better than this. Maybe this, as you can see. This is my approach. This is my new approach of hybrid training. Hybrid training, that means we can create something like this and isolated feature very, very, very well. So I can see the feature very isolated by combining the predicted gamma ray, predicted VB and VS, and others prediction and this data. So this is one of the techniques I use. But the problem now, we need to think about the data analysis, because if you don't choose correct data and choose best attribute, the result may be not good. So as you can see, I already created some data analysis here to show you. I think this is one of the data analysis. This is univariation, distribute data in one direction. Which one is good? Maybe this is good, maybe this is good, maybe this is good. The good depend on the change of class. The value here completely isolated from here. So this is good, sweetness is good because we have high isolated value from this. It's good. High variety of data also is good, and now we have also other instantaneous amplitude still good because it is isolated data from other. Maybe this is a Bayesian or interested reservoir from other. Still instantaneous frequency, I don't know, the same value here is maybe low, maybe it is accepted, but not like sweetness. Also correlation is good also. Questions, because now maybe we have just 5 minutes to finish. We can, if anyone have any question, can send in chatting, and I will answer directly if anyone have any questions about this. Also, we have cross-plot between data with each other. So now we can, this is multivariation between attribute, and see instantaneous amplitude, sweetness, instantaneous amplitude, and the relative acoustic impedance, good relation, bad relation here between instantaneous and the others. So now we can analyze data, and this is variogram, and we can also change the model because we predict data laterally, not vertically. So we can identify data we have. This is data analysis. We can see another data analysis. I wish it is work. Okay, this is another data analysis. This is different from previous. The previous without phases are unsupervised. So now I can have option to test data without phases or with predicted supervised. So that means it is not performance of algorithm, it's just data analysis to see how much the data contribute in your model. So now I think if you want to ignore the phases predicted, so now we can see the performance of data. If you wanted to test specific phases, maybe I interested in the red one, and maybe the confuse of other, I will ignore this and this and this and see the change. Maybe the red is good and isolated, maybe confused in this BCA distribution 2. I can ignore principal component 2. Maybe 3 is a little bit better, and maybe 1 is still good because it is partial isolated between the green and red. So this is good because this is like PDF and tested the contribution between different clusters and how much to isolated data, and this helps to choose best attribute in your prediction. Also can have correlation, also can have cross-plot, variogram, the same techniques. So this is for data analysis. Let's start to test the performance. Yes, it is available for trial. Some people ask it, but not for. Also, we have academic for any university, but we need legal from university. If anyone wants software, I can help you to have demo, but you must have a formal email for this. Also, the difference between this and this, we have something called okay. So now I will speak about the performance. The performance is different from analysis. The analysis is mean we test data and see how much data contribute, but performance we test the software itself, algorithm itself. Let me show you what is the difference. This is performance of regression. So we make a relation between, I want to predict like gamma ray or any thing. So this is the predicted data, or this is the real data. So we have important. So this is the priority of important of each